So today we're going to start going into more detail about how to program with completable futures. And we're going to start initially by discussing basic completable future features. These would include things like the get and join methods, is done, is canceled, cancel, complete, and so on and so forth. So we're going to showcase these basic features in the context of case study EX8, which you can get here at the EX8 project in my Java 8 folder in the Live Lessons GitHub repository. And I'll both show code throughout this discussion, and I'll also show some interaction diagrams that are shown here on the right-hand side. But before we get into the code, let's first just quickly recap what CompletableFuture supports with respect to basic features. So it supports the so-called Future API. We've seen that before. That's an interface that was been around since Java 5, about 20 years ago. Some of the things you can do with the Future API, you can block by calling get. You can block by calling get with timeouts, either to doing polling if you give a timeout of 0, or so-called timed waits, which will wait for a certain amount of time in the given time units, like milliseconds, seconds, microseconds, and so on. You can also cancel or check to see whether or not a future has been canceled. You can check to see if a future has been done and finished, and so on. One of the things that's a little quirky here is that cancel doesn't interrupt the computation by default. So this is very odd. You can read about why it doesn't do it if you read this link here, but it kind of makes it useless to cancel completable futures unless you do a lot of extra work, which most people aren't willing to do. One of the things it adds that's a little bit different from what you would get with just the basic future interface is this ability to define a join method. Now, what join does is it blocks awaiting the results, just like get does if you pass no parameters. However, it behaves like get without using checked exceptions. So if you recall, Java has checked exceptions and so-called runtime exceptions. Checked exceptions have to be checked syntactically in the code unless you do exception laundering. In contrast, join doesn't use checked exceptions. So you can use it in a Java stream like this. If you had a list of futures, you could stream them, and then you could join each of the futures by calling map with completable join as a method reference, and then you could collect the results into a list. In contrast, if you tried to use future get, then you'd have to use a try-catch mechanism, try-catch construct, which just looks ugly. I mean, compare that with this. This is obviously much cleaner, much easier to work with. And you could try to use get with exception laundering as described at this link, but that's really overkill, once again, compared to this nice, clean join call, which uses runtime exceptions. So little teeny-weeny minor improvement based on what you get out of the box. Oddly enough, there is no timed version of join. And I guess the motivation for that is they really don't want you to be using the timeout version of get, so they don't want to propagate that with a timeout version of join. But anyway, I've always thought that was a little bit odd. Something else you can do with basic completable future features that you cannot just do with basic future features is you can complete them. So if you make an uncompleted completable future, which is kind of like the donut with the hole in it, then you can come along later and complete it, which is like giving the donut hole with the donut. And we'll talk about some examples, and you'll see how to use that. Here's a simple example that's not unlike one we'll look at in more detail when we get into the actual code walkthrough. What you do here is you make an incomplete future, and then you can spawn a thread, which will, of course, run in the background somewhere. And after that thread has been spawned, then you can have that thread running concurrently with the calling thread, the main thread, and then at some point this future can be completed by explicitly completing it, and that will allow any calls to join or get, if you choose to use get, which you should not do. Any calls to join will be able to return at that point with the results of the completion. Another thing you can do, which is important when you do your next programming assignment, assignment 4, is you can initialize a completable future to a completed value. So in this particular case, we're creating a field called 0, which stores a completed future, which is the value 0. And then if you want to use that down here for whatever reason, typically for something like maybe error reporting or whatnot, or the default case of something, then you could say future complete 0.join. And that call will immediately return because we created a completed future with a particular value. So that comes in handy for some things to make the code a little bit cleaner. You do not want to use a completable future factory method here, like supply a sink for the value 0. That's overkill. That's not necessary, and you can use the completed future mechanism instead. OK, so that is the end of the overview of basic Java completable future features. Now we're going to walk through some code that will really make it come to life.